Okay, good morning class. You're on to MAMU with Jarvis, Mathematics Experience, and this is grade 8. Grade 8 will mean JS2, depending on the part of the world you're learning. Today we'll be looking at an aspect of mathematics that borders around arithmetic. To be very emphatic, we're looking at whole numbers. I have two favorite textbooks of reference. The New General Mathematics for JS2, which you call the grade 8, and oh, my favorite, Essential Mathematics for grade 8, which is JS2. This, for me, is my official text in trying to pass the multiverse concept of mathematics to our young generation. Today we're looking at something we call whole numbers. Now, what is a whole number? Interesting question. But I think the most important thing to understand first is to look at what we call numbers. So what is a number? A number is a symbolic representation of quantity. A number is a symbolic representation of quantity. Numbers are used to talk about quantity. If I ask how much, what you're going to tell me will be, say, 100 naira. 100 there suggests what? A number. If I ask you, how far is it from YKC to Abek? You want to say maybe 10 kilometers. 10 there talks about what? A number. But we also have a special class where we handle things like that. But today we want to keep it as simple as possible. Now, I just told you what a number is. The next interesting thing we want to know will be, what are the types of numbers? I've done extensive videos on all of this, so I'll just keep them very, very simple, and then you can look up my other videos and get these explanations better. Now, types of numbers. Essentially, we have 5 types of numbers. 5. We have what is called natural. We have what is called integers. Or more importantly, we call them directed numbers. Directed numbers. We also have what is called rational numbers. And we also have what is called irrational. And for those of us that will one day want to become engineers, scientists, as the case may be, you will come to a realm to call complex numbers. So I haven't classified numbers. Numbers will fall under these 5 major categories. Number 1, natural. Number 2, integers. Number 3, rational. Number 4, irrational. And number 5, complex numbers. At grade 8, which is JS2, you should be conversant with natural numbers, integers, and what? Rational numbers. That will just be okay for you for now. Irrational, complex numbers will come up later. Okay, that's just by way of introduction. So now, when we're talking about whole numbers, in context, we are talking about a number that is positive. Because when we're talking about whole numbers, generally we want to talk about whole numbers as natural numbers and what? Maybe stretching up to integers. But I'll keep it simple and say that at your level, we're interested in whole numbers as what? Natural numbers. So a whole number in our context is a natural number. I'm careful to use the word in our context because that's not a complete definition. But I will just keep it that at least that a whole number in our context is a natural number. So what's a natural number? A natural number is any number that is whole and positive. A natural number is a whole number and it is positive. A natural number is a whole number and it is what? Positive. Okay, that's about the introduction to numbers, but that's not where we are going to. Now we're going to be exploring different aspects of whole numbers or natural numbers, if you choose to call them that. The first and the most important natural number type we want to look at is what I call the prime numbers. Prime numbers. Prime numbers. And at grade 8, you are expected to be able to tell the prime numbers between 100 and 200 in less than 2 minutes. Wow. Is that possible? Very, very possible. It takes practice. You know, in MAMU we believe in what? Interest, practice, and what? Courage. So, prime numbers, we're going to try to list them out. And I use my 5-5 formation. 5-5 formation to get this. Now, we start with the first one, 2. Hello, 1 is not a prime number. 1 is not a prime number. 1 is not a prime number. So the first prime number you have is what? 2. Hear this. 2 is the only positive prime number. So if 1 is not a prime number, what then is 1? 1 is simply a neutral number. So add another information. 1 is a neutral number. 1 is a neutral number. Are we learning something? I trust you are. 1 is not a prime number, but it has an identity. It's called a neutral number. Why is 1 called a neutral number? I'll tell you why. If I imagine 1 to be my denominator, you have been taught fractions, I trust. So what's a fraction? A fraction expresses 2 whole numbers. Let's say 2 over 3. That's a fraction. But if I say 2 over 1, the answer will be what? 2. 1 got its name neutral because when it sits as the denominator, it does not do anything to the numerator. I'll come again. 1 is called a neutral number because when it sits on the denominator side, it does nothing to the numerator. So what it does is that it keeps it the way it is. And that's why 1 is such a very unique number. Okay, we're done with that. So we know that 2 is the only positive prime number. And in addition to that, in arranging prime numbers, 2 is the first. Do you get that? Alright. So we have 2, we go to what? 3, we go to what? 5. If I'm wrong, you draw my attention. Even teachers sometimes we make mistakes. The next one will be what? 7. And what's the next one? No. 9 is not the problem. 9 is not a prime number. Now, notice that I did not start by defining what a prime number is. And I did that intentionally. More often than not, when we learn, we want to give you definition. But sometimes it's best you understand the definition as we begin to study. Now look at this. 9 is not a prime number because a prime number has just one factor, and that's itself. So we define prime numbers as a number that 1 and itself can divide. So what's a prime number? A number that 1 and itself can divide. So a prime, if you look at 9, I can get 3 from this 9. Is that not? I can also get 9. 6, are you sure about that? 3 and what? 9. We can get 6. Why? Because then you're taking my direction to factors. What are factors? One of the basic and fundamental rule about a factor is that a factor goes to solve a problem. Oh, I just got that understanding now. A factor goes to solve what? A problem. How does it solve the problem? If, for instance, I bring factor 3, the negotiator in this transaction, and I bring him to solve the problem of 9, what factor 3 will do is to tear 3 into 3 parts. Is that not? And it was 3. Is that not? So, factor 3 is a factor because it would break 9 so that I will not have a remainder. It's so important. A factor does not leave a remainder. If it leaves a remainder, then it has lost its identity as a factor. Very good. Okay. Now, we stopped at 11. I said I'm using my 5-5 model. I use this because it's easier for me to remember them. And you're going to see the reason why I'm using this. Next one we have is 13. Next one will be 17. Next will be 19. Now, as I'm doing this, watch the numbers. These are numbers that don't have factors other than themselves. Now, look at this. 23, good. What's the next one? 27, 29. 27 is not there. Look at 27. 27 is a number that has factors of 3, 9, and what? 27. When we're talking about primes, we must imagine a number that has just itself as the only factor possible. Next one will be 31, next will be 37, next will be 41, next will be 43, next will be 47. The next, notice that after the first 5, I go to the next 5, I go to the next 5, next will be 53, I was right about that, 59, 61, 67, and possibly 71. I'm right with that. The next one will be what? 73, 79, 83, 89, and 97. So, conclusions from this. For your first 100 numbers, there exist 25 prime numbers. So, I'm going to write that somewhere. For our first 100 numbers, there exist 25 prime numbers. For our first 100 numbers, there exist what? 25 what? Prime numbers. So, why is the concept of prime numbers so important? Why then is the concept of prime numbers so important? It is important because if you look at the prime numbers we have studied, when we start to treat LCM, HCF, what essentially we are using to divide will be what? Prime numbers. When we come to LCM, HCF, common factors, common multiples, you get to appreciate why you need to remember the first 25 prime numbers. So we'll pause for now. Our understanding of prime numbers enable us to handle what is called product of factors. We have said before that a factor essentially is a whole number. So let's by way of having our footnotes, a factor is a whole number. At least at your level, a factor is what? A whole number. Now, in looking at product of factors, we will be trying to use our prime numbers, our concept of prime numbers to handle them. Now, hear this. If a factor is a prime, we call that factor a prime factor. A prime factor is a number that is a prime. Let's keep it very simple. A prime factor is a number that is a prime. I'm using the word prime to teach something better. Because when we come to algebra, you will see prime in another context. That's what I call algebraic primes. So I'll use prime just to prepare your mind for what is to come. Now, a prime factor is a number that is a prime. We've already listed what prime numbers are. So let's say, for instance, you are told to write a number as a product of its prime factors. So we could be told to write 24 as a product write 24 as a product of its prime factor. Thank you very much. Of its prime factors. So what do you do? Now there are two ways you can do this. There's what is called the factor tree, and there's something we call the division method. There are two methods to handle this. So I'm going to try to show you both methods, and you make your decision on which method appeals best to you. So here, using a factor tree, what can multiply 24? What can multiply 24? 2 times. Is that not? Yeah. So I've taken care of this. I don't have any problem with this side now. So I'll come to this. What can have again? 2 times what? 6. Now taking care of this, what can happen to this? 2 times 3. Now, this method requires you to count the 2's you have. I see that. So if I'm not writing in index form, which is something we'll come to later, I'll have this. So if they say write as part of its prime factors, you look at, in arranging your tree, where are the primes? Where are the primes? I see that these essentially are the primes. So you write them here. Now, you could be asked to write in as a product of prime factors in index form. If you're told to do that, what you simply do is to check. You count. How many 2's are you seeing? 1, 2, 3. So that will be 2. How many times?
3.
Times what? 3. And that will be the product of its factors in what? Index form. Are you seeing that? Now, what is an index? Because looking at this, the question will be, what is an index? An index tells us how many times a particular number is multiplied. An index tells us how many times a number is what? Multiplied. So, an index gives us an idea of how many times a number is being multiplied. So if I have 2 index written like this, 2 index 4, it will mean that 2 is multiplied how many times? 4 times. So that takes care of this idea. Alright, so we've done this. So I guess this is the tree method. So I'll call this the factor tree method. So somewhere in your book, you just write factor tree method, factor tree method. This one we call the factor tree method. Factor tree method. There's yet another method we can use, which some books will call the division method. That's what is most taught in schools this way. We use the division method. Now, I'm going to upgrade on that method because you need to understand why you are using that method and how you use it well. Now look at this. This is 2, this is 24. That's 24. So, how do we go about it? We start by, this column is what I call the prime column. What I call it? The prime column. What it means is that the only numbers that can appear here must be what? Prime numbers. They must be what? Prime numbers. So we start. Because this number is even, the first prime number we're going to use here will be 2. Now, if we pick a prime number, we must exhaust the division before going to another number. So 2 into this will give me what? 1 here, 2 there. I bring another 2, this will give me 6. I bring another 2, this will give me 3. And then, because I have exhausted all the 2, I check what's the next prime number that can divide this, and that will be what? 3. So I'll use 3. So with this method, we discovered that 24 will be equal to what? 2 times 2 times 2 times 3. And which we can still write as 2 index 3 times 3. Now notice that in putting this idea together, I'm not following a systematic approach. I'm putting the ideas as they come. Because when you want to do your revision, sometimes it's good you're able to see different aspects so that when you're doing your revisions, you're not, how would I be able to solve this question? So that's for product of factors. And I'm trusting that with this little explanation, when you go in to solve your own problems, you'll be able to handle this better. Okay, we will go in to look at the last concept for today. Borders around factors and multiples. There are lots of things people say, factors this, multiples this, but I'm going to give you a very simple. A factor carries out the assignment of dividing. A multiple, as the name implies, means to build up, multiply. So when I multiply factors, what I obtain is a multiple. When I break multiples, what I obtain is a factor or factors. That's it. It's not more than that. Some of us don't have strength to begin to. So it's as simple as that. A factor carries out division. A multiple implies multiplication. So let's practicalize this now. But remember that whether you're talking about multiples or factors, they're essentially what? Whole numbers. So let's practicalize this. Look at, if I have 6 as a number, 6 will be 2 times 3. Is that not? Yes. So these 2 and these 3 are treated as what? Factors. Why this 6 is the multiple? I've already started to tease something. Follow me closely because you're going to see something that will be very, very, very funny now. Follow me closely. So 6 will give you 2 times 3. These are factors coming together. Back in the days, we used to watch a cartoon called Voltron. I think there's something close to that today. Go Power Rangers. Yes, I think I'm correct. They come together and they form a bigger, yes, so that's what's happening. So each of those characters you have, the Power Ranger, are factors. Whatever they are transforming to is called the multiple. You understand better now. You must understand that one. Alright, so we are done with multiples and factors. Now, when we have, listen, when we have numbers and we want to compare them, we will start hearing things like common multiples or common factors. See, I'm not following your normal textbook approach now. I'm trying to keep it very, very simple. Now let's take an example again. I give you 12 and I give you 18. There are two things I can do here. I can talk about factors. I can talk about multiples here. But let's assume for now I want to treat let's say factors. Let's say common factors. Now when we're talking about common factors, now look at, if I say common, it means I'm comparing. Hear this. Anytime you hear the word common, it means you are what? Comparing. So I pick two things. I want to look out for what I can see in this thing, and I can also see in this other thing. That's common. So mathematically, we talk about common factors. So let's look at it. Let's use the method you know. 12, 18. Is that what? Yes. Remember that I call this column my prime column. The only numbers I can visit or occupy this column are called what? Prime numbers. They are called prime numbers. So this will be 2 into 12, that will give me 6. Into 18, that will give me what? 9. Hear this, in using this method, because there's another method we learned in primary school. When you are treating common factors, there's another method we learned in primary school. I don't know if you remember. You do them separately. I'll take 12, I'll do it separately. I take 18, I do it separately. You are past that stage. Amen. You are past that stage. What you are doing now is this one. You put everything together. So if I pick 2, the 2 must divide this and this. Because you are talking about factors. It must divide this and this. I can't pick 2 again because this is 6 and this is what? 9. I seen it. So I'll look for what is after 2, what's the next number or prime I can put here? 3. I will now check if that 3 can divide 6 and 9. Yes. Good. So that 3 will come in. And when you divide this, you need to get what? 2 and 3. So with this, I will have that common factors will now be 2, will now be 3, and also 2 times 3, which will give me what? 6. I present to you another secret. Every number is a factor of itself. 6. So what's the factor of 6? 1. Okay. 2. 3 and itself. So let that lock in. Every number has a factor, has a very important factor, and that number is itself. It must be present. You know all this, rather you know these all, but I'm just trying to give you little things that you just, okay, so common factors will be 2, 3 and 6. Is that not? Now, your teacher, based on this previously, now teased a new series called HCF. No Way Home. Spider-Man. Lovely. So, what is the HCF? Amongst the factors that are common to this number 12 and 18, there is one that is the highest. And if you have eyes, you will discover that number is what? 6. So that's why the HCF is obtained first of all by knowing that there is something called common factors. And amongst the common factors, there must be an equal, and that equal is what? 6. As simple as that. And that settles that. That's it. It's that simple. So we treat common factors. Now, we also try to treat common multiples. Okay, that's the much time allowed us today to take on the concept of whole numbers. And by way of summary, we've been talking about prime numbers. We talked about types of numbers. We talked about We talked about factors, common factors, and in our next class we try to look at multiples in the context of common multiples. Thank you for joining us in our class this morning. MAMU with Jarvis will return. Thank you.